Okay, so we're still in chapter 3 and we're working through derivative rules, and finally we're going to get to the product rule, like I promised we would after we did chain rule and trig functions. And so basically the product rule is when y is u times v, then y prime is equal to u prime v plus v prime u. What does that mean? Okay, so basically it means when you've got two functions that are multiplied together, you take the derivative of one function, leave the other one constant, take the derivative of the other one, and leave the first one constant. And let me just give you an example. Okay, so let's start with an example, and everybody always goes, okay, so here I'm going to do this one. X squared times x cubed plus 3x. Let's just make it a little bit harder. Okay, now lots of people say, well, why can't we just FOIL this one out? Why can't we just say that this is x to the fifth plus 3x cubed plus x cubed plus 3x. So why can't we say it's y equals x to the fifth plus 4x cubed plus 3x? And the answer is you should. And then we take the derivative of that and we get 5x to the fourth plus 12x squared plus 3. Okay, that's the way you should do it. This is not a product rule problem, but we're going to use it as an example because now we know what the answer is. So using the new method, we should hopefully get the same answer. So we're going to use product rule on this one where we don't need to, and then I'll give you some product rule examples where you absolutely need to use the product rule. There's no way around it. Okay, so what we're going to do is we're going to say u is equal to x squared plus 1, and v is equal to x cubed plus 3x. And we're going to say u prime is equal to 2x, v prime is equal to 3x squared plus 3. And then we're going to say y prime is equal to u prime v plus v prime u. And so that's going to be my u prime is 2x, my v is x cubed plus 3x, plus my v prime is 3x squared plus 3, and my u is x squared plus 1. Okay, so then if I FOIL those out, I'm going to get y prime is equal to 2x to the fourth plus 6x squared plus 3x squared, x to the fourth rather, I'm sorry. First, outside gives me 3x squared, inside gives me another 3x squared, last gives me plus 3. And so combining like terms, I've got y prime equals 2 of those and 3 of those makes 5 of those. 6 of these plus 3 of these plus 3 of these makes 12 of those. 12 of these. And then I got this plus 3 hanging out on the end. And you see that they're the same. So product rule works. Okay? Now, so the question is, so we want to get into some ones where product rule is the only way to do it. So let me give you some product rule examples where product rule is the only way to do it. Y is x squared times e to the x. Let's just start off simple. Okay? So then I'm going to say u equals x squared, and v equals e to the x. U prime is equal to 2x. V prime is equal to e to the x. And so then my y prime is going to be equal to u prime v plus v prime u. And I'm just going to rewrite it as x squared plus 2x times e to the x. And that's what I'm going to say is my answer. Okay, another one. Let's do y equals square root of x times tangent x. So I'm going to say y equals x to the 1/2 times tangent x. I'm going to say my u is equal to x to the 1/2, and my v is equal to tangent x. My u prime is equal to 1/2 x to the negative 1/2. My v prime is equal to, can you remember that one? Secant squared x. And so then my y prime is equal to u prime v times v prime u. Okay, and that's another one. And let me give you, let's just do one more, just sort of a big one. So let's do y is equal to cosine x squared plus 3 times e to the times e to the 3x to the 5th plus 2x to the 4th. Let's do that. So now we've got product rule and chain rule together. We got product rule, we got chain rule, we got power rule, we got exponents, and we got trig functions. So we got it all. But we just got to break it down into little pieces. Okay? So what I'm going to do is I'm going to say u is equal to cosine of x squared plus 3. And I'm going to say v is equal to e to the 3x to the 5th plus 2x to the 4th. But now we got functions inside of a function. So let's say, what variables do we want to use now? Let's use p and q. So now I'm going to say u is equal to cosine p, and p is equal to x squared plus 3. And I'm going to say v is equal to e to the q, and q is equal to 3x to the 5th plus 2x to the 4th. Well, now I'm going to say u prime. Well, I'm going to change it around here. I'm going to say du dp is equal to negative sine p, and dp dx is equal to 2x. And I'm going to say dv dq is equal to e to the q. That's an easy one. dq dx is equal to 15x to the fifth plus 8x to the third. Then I'm going to say du dx is equal to those two multiplied together. So negative 2x sine of x squared plus 3. And dv dx is equal to that times that, and my q is that. Whoop, sorry. So one of the things is, hopefully if you're working along, you caught my mistake. And hopefully if you're working along and hitting pause, you're catching my mistakes before I catch them. That's the ideal. Okay, so now I'm going to put a little circle around that. I'm going to put a little circle around that. I'm going to put a little circle around that. And I'm going to put a little circle around that. And I'm going to say dy dx is equal to, I can either do this times this plus this times that, or I can do this times that plus this times that. It's just these two multiplied together plus these two multiplied together, however you want to write it. So I'm going to write it as cosine x squared plus 3 times 15x to the fourth plus 8x cubed e to the 3x to the fifth plus 2x to the fourth plus, there's a minus right there, minus 2x sine x squared plus 3 times e to the x 3x to the fifth plus 2x to the fourth. Okay, so really a lot of stuff in there. There's just a lot of stuff in there. But what I want to show you is you just break it down into simple functions. U equals cosine p. The derivative of that, du dp, is negative sine p. You know that. P equals x squared plus 3. dp dx is 2x. You also know that. The derivative of e to the q is e to the q. You know that. The derivative of 3x to the fifth plus 2x to the fourth is 15x to the fourth plus 8x cubed. All of this, all the stuff that's in this line, in these two lines right here, are simple stuff that you know. And it's just how we sort of chain them together with functions inside of functions, functions inside of functions, and functions multiplied by other functions, that it gets complicated. So break it down into simple steps and then do each simple step. And that's that lecture.